Okay, so users and developers for the Kubeflow training operators. My name is Wang, and I'm from Tencent. In this section, Jiaxin from ByteDance and I will talk about the new approach we plan to move the Kubeflow training operator to the next milestone. But first, so let me introduce some background about the distributed training on deep learning and briefly recap how these existing training operators in Kubeflow community to realize different training mechanisms on Kubernetes. Then Jiaxin will discuss the situation and pain points for the current training operators, followed by our proposed solution, a unified training operator, which we believe shall address these issues Kubeflow training operators are facing right now. So this is a topic we are going to cover in this presentation. And before we talk about how distributed training works on Kubernetes, let's recap why we need the distributed training for deep learning. With rapid growth in both dataset and deep learning models, there emerged two approaches with distinguished parallelism. For a large data set, the data parallelism take 1 minute batch and divide it into multiple micro batches. Each micro batches is fed into one training operator and goes through the forward pass. Then the backward propagation starts, gradients are generated in this pass, and the value will be averaged before applied to the weights. On the contrary, if it is a training model that it is too big, as one single machine cannot hold the entire copy of the graph. Pipeline parallelism lets each training process take over part of the entire graph and orchestrate the pipeline for each parted segmentation to perform forward and backward computation. Instead of communicating with the gradients like the data parallel does, the communication between pipeline parallelism transfers the input tensor between edge ops on each segmented subgraph in both forward and backward phases. So parameter server mode appear as the first widely used distributed training mechanism for both data parallel and pipeline parallel. There are two major roles in this approach. The worker that perform forward and backward computation to generate gradients, and the parameters which is responsible for three actions. The first is receiving gradients from workers and serving or sending weights to the workers, as well as updating weights it hosts with received gradients. For some implementation, there might be another helper role in this scenario, which is usually called, which schedule or coordinates the distribution of all communication of data and operations. So when applied to the data parallel, each worker constructs the identical and whole graph locally, and pull weights from the parameter server, perform the propagation and sends back the gradients. With different updating mechanism, this mode supports synchronized and asynchronized distributed training. Parameter server mechanism also supports the pipeline parallel training. In this mode, the entire graph will be divided into multiple subgraphs and assigned each worker. So each subgraph will be assigned to a specific worker by the coordinator. Apart from the same action performed in data parallel, the parameter server also works as a shared data storage for transfer, the tensor input we mentioned before. Deep learning framework like TensorFlow, especially TensorFlow version 1 and MXNet generally adopt this mechanism to provide the distributed training capability. The other distributing mechanism is mostly designed for synchronized data parallelism. In this mechanism, each training process is a worker, and there's no parameter server. So instead of submitting gradients to the parameter server, the workers use this mode. Workers in this mode use or reduce operations to average gradients on each worker and update it to the identical local weight copy. While this diagram shows the workers use ring or reduce to average gradients, other or reduce schemes like tree or reduce are also able to finish operations to of averaging the gradients. We'd like to further explain the initialization phase up here for this distributed training mechanism. Before the training starts, all workers except the worker with rank 1, which we will call the worker with rank 0, which we will call it worker 0, need to register themselves to the worker 0. The worker 0 will wait until the number of registered workers reach the water size -1, which means all workers, including itself, is ready. The PyTorch framework uses this mechanism to carry out its distributed data parallel feature. And in TensorFlow, even for the same parameter server mechanism, there are two variants. The early version is in a multi-client mode where each role, no matter it is parameter server or worker, will have a copy of tfconfig, which stores the identification of all the participants of this distributed training and the self-identification of each training process. This training process will share the same mechanism to divide the entire graph and to perform different works. But in a more recent version of TensorFlow, additional role is introduced, which we call a coordinator, and it converts a tfconfig into a cluster resolver, which is tfconfig resolver. It helps the coordinator to partition the entire graph and distribute the subgraph to different training process. In this mode, other training process just need to start the server mode and wait for the command from the coordinator to be received. Since TensorFlow version 2, a concept called distributed strategy is introduced, and now TensorFlow can support both the all-reduce style multi-worker distributed training as well as its original parameter server training. So both the industrial and academia widely use training operator from Kubeflow community to deploy machine learning tasks on Kubernetes. Now let's check how Kubeflow operator works, and especially how these operators let container discover each other's in the same training task. Here's a table, and in general, operators need to convey the consensus of training task to all its participants. Here's the consensus includes all the participants' identification as well as registry or discover information. We can categorize operators into two groups by how the consensus is passed to containers. The first category includes TF operator and MXNet operator, which inject a single environment variable for configuration. Training process can parse the configuration environment variable and determine the self-identification as well as all other participants. Other operators like PyTorch operator and the XGBoost operator only tells the self-identification, which is the rank number, and the registration information, which essentially is the address of the worker zero. This is how the consensus is attached to each containers. If we talk about the generic architecture of setting up Kubernetes resources for distributed training tasks, there is an operator, and it listens to the API server for targeted job like customer resource. It then will process the spec field of the custom resource and create pods if the pods needs not to be discovered. For pods needs to be discovered like worker zero in PyTorch DDP, service will be created as well and attached to the target pod. And more importantly, the operator will inject the environment variable, which may be the configure environment variable or the master address to each pod, and make sure the training process can read the consensus for the task. Here is an example for TF operator, and this TF job specifies 2 parameter server and 4 workers. So the TF operator generates pods with serverless service attached to each pod, because in the initialization step of TensorFlow distributed training, the training process will reach out to each other and confirm the training related metadata. That means both worker and parameter server needs to be discovered. The TF config environment variable keeps the cluster information identical among all pods in this job, but change the task value here to as each pod has different type and index. We have to mention that not all training operators in Kubeflow community designed in this way. MPI operator follows the existing MPI standard and encode the consensus into a host file. So there are more additional processing in MPI operator to make sure that it is compatible with the pre-existing standard. That includes like access control for the launcher pod, but we leave this as a special case as most training operator follows the generic approach we mentioned in the previous slides. Okay, now Jiaxin will lead us to discuss the situation of training process and training operators and the issues we are facing when developing and maintaining these projects. Jiaxin?
Hi, hello. Let me share my screen and continue the talk. Okay, cool. Hey everyone, this is Jiaxin. I'm a software engineer in ByteDance. I'm working the TikTok and ByteDance internal infrastructure and mainly focus on the Kubernetes and cloud native technologies. Before ByteDance, I was in AWS EKS team and lead the big data and ML strategies on Kubernetes. So I start to contribute to Kubeflow since 2018 and spend the time on different projects. And so currently I'm concentrating on the training side. So I'll talk about the current training operator situation. So what's the current status and any pinpoints in the project management. So as we know, like Kubeflow is a machine learning toolkit on Kubernetes, and it includes different kinds of tools that aims to solve problems in different ML stages. So training plays an important role here, and it provides the primitive model training capabilities to other components. So there's multiple components highly integrate with training job. So the first one is the CARTIP, the hyperparameter training solution in Kubeflow. CARTIP runs several training jobs known as trials within each hyperparameter training job, which is the experiment. And the second one component to integrate with training is the pipeline. So there's some reusable training components, and you can easily leverage them to orchestrate your ML pipelines. You just need to fill those like parameters, and the reusable component will take off rest of the things. So the third one, because we already, I think in today's like previous talks, people already covered the like CARTIP pipeline details. I won't spend extra time on it. So I would like to spend some time talking about the third component interacting with training job, which is Fairing. So Fairing is the Python SDK, which can streamline your process of model training and deploy models in a hybrid cloud environment. So let's look at the code snippet here. So since Fairing will package your training codes into the containers, so you will need to configure the container registry informations. So after you finish your training code, you can embed your code in a training job wrapper and run it in your like Jupyter notebook. See the last code blocks. So you can write a class called housing serve, and it should implement a train method. And the training job is a wrapper. So when you execute this code in your notebook, the Fairing in the background will package your code, build the container images, and then kick off the training jobs in Kubernetes. So this is a pretty good tool for those like data scientists who's not familiar or don't like to build images or use Kubectl to leverage the training operators. So in the past 3 years, there are 10 training operators in total that contributed to Kubeflow community. I think the first few frameworks are the most popular ones, and people should be pretty familiar with them. We have 2 operators actually planned to archive pretty soon. So the first one is Chainer. So the Chainer operator was contributed by Preferred Networks in Japan. So which is the company founded Chainer project. The Chainer project was the preferred framework for dynamic computation graph. So as PyTorch and MXNet, they both support dynamic graph. A few users moved to those frameworks, and the Chainer operator in the end is not that actively maintained. The second one we like to archive is Cafe 2. So Cafe 2 is a lightweight and module frameworks for training and deployment. So Cafe 2 is built to excel at mobile and at large scale deployment. I think like 2 years ago, Cafe 2's community determined to combine the beneficial traits of Cafe 2 and PyTorch into a single package and enable a smooth transition from fast prototyping to fast execution. So that's why the Cafe 2 operator is not actively maintained. So last year in 2020, we have Fate, which is a federated machine learning joined Kubeflow. So it is the operator joined the Kubeflow. It is a machine learning setting where many clients like mobile devices can collaboratively train a model under the coordination of a central service while keeping the training data decentralized. So this is not a framework binding. So that's totally a different way to federate your model trainings. In 2021, this year, we have 2 proposals in the community. So Paddle community contribute their operator to Kubeflow. So Paddle is originated from industrial practice with some dedication and commitments to industrialization. So it's pretty popular in China. And at the same time, the DGL, which stands for Deep Graph Library, we are still reviewing the proposal. It simplify running the distributed graph neural networks in Kubernetes. I hope it can join the community pretty soon. So that's the status of the current operators. So as you see, as community continue to grow, more and more distributed like training frameworks are supported in Kubeflow. Well, some of the operators looks pretty similar. So the community kicked off the refactoring works since 2019. So we made some common types available in a standalone repo called Kubeflow common, to reduce the code duplications and provide a clear pattern for long-term API governance. A lot of things like drops the success policy or failure policy, like replica type, etc. So those are all extracted to that common repo, and they are generally used in all operators implementations. In 2020, we enhanced the maintainability of the common module and provide a base drop controller for other frameworks to easily implement their own operator. So this screenshot actually shows the container interface. So for any framework, if you like to build like a Kubeflow like training operator, you can easily integrate this interface and leverage the metro-based controller like we built. So working group training also migrate all the operators to leverage the common module last year. Kubeflow common in the past year helps a lot in sharing common types and implementations. At the same time, the drop API becomes fairly stable, and most of the operators implementations now look pretty close after migrating to use a common drop controller. However, the project maintenance is still an outstanding problem these days. So we start to discuss if we like to merge all the operators into one at the end of 2020. Let's talk about the current challenges. So there's two categories. The first one is the maintainer challenges, or the project maintenance challenges. We feel it's very hard to keep the framework independent features like the SDKs, like log format or metrics and bug fixes consistent across all the operators. For example, if someone found a bug in the PyTorch operators, okay, we noticed that should be applied to all the rest of them. But the maintainers have to be aware of this change and compare the differences between those operators and then submit the changes. So it's very hard to track the differences. And we noticed is also for all the operators, it's very hard to reuse the Kubeflow's shared testing and release the infrastructure. If you take a look at all the operators today, still some repos use the Docker Hub and some use some GCR or like AWS public registry. As we talked earlier, there's a lot of Kubeflow components actually interact with the training components like the Kubeflow pipeline, Cartives, and some other tools. So we notice that's the kind of a duplicate efforts to build those components or clients to interact with these components. And that's definitely not a scalable way. So maintenance efforts increase linearly with the number of the supported frameworks. Is also there's a learning curve for new engineers or developers to contribute, and they have to learn the differences between the operators as well. That's all the challenges we are facing today. On the user side, there's also some problems. So users who like to use multiple frameworks, they have to install all the operators. So that's duplicate efforts, definitely some efforts on the like the log metrics or manifest management or integrations with their own like observability infrastructures or environments. And between different operators, the drop spike looks slightly different, and it actually doesn't give user a consistent experiences to use them. So that's why I think in order to address these issues, the working group training determined to prioritize the universal training operator proposal this year. Yeah, if I think people have the interest, you can click the link later, or we will share the slide to get more details of the doc. Today we can briefly talk about the proposal. So what we plan to do is to consolidate all the operators into one. So only one controller manager is needed to manage all the the framework level controllers. So each deep learning framework will have its corresponding job controller. This helps further eliminate the code duplications and standardize more things like the SDKs, logs, metrics, etc. So what's more, it enables some performance enhancement, such as only one shared informer cache for all the controllers, reducing the number of the requests to Kubernetes API servers. So this doesn't mean you have to install all the frameworks. So user-specified controllers can register themselves to the manager in a configurable way. So this helps users to scope down the frameworks they like to use instead of enabling all controllers. So if you look at the code snippet here, we plan to add all the frameworks support in the single repo. And when we start the operator, we create the new controller manager. And based on the configuration, based on user settings, the different framework level controller will register themselves with the manager and start to listen and watch the jobs you created or deleted. Yeah, so the idea is pretty simple, but the code is more on the refactoring side. So the major code changes, first thing, a lot of operators were written using the low-level controllers. And Kubebuilder is pretty popular in the community, and most of the operators are written in Kubebuilder, and they save a lot of efforts on those low-level codes management and simplify the logics. So we determined to rewrite those controllers to use the reconciler model, which is provided by Kubebuilder. And we still use Kubebuilder and the code generator together to manage the API and the controller skeleton codes. So Kubebuilder is not won't build everything for us. So the code generator is still being used to guarantee we can generate the client size for other components to interact with, generate some defaults, etc., and open API, etc. On the code level, we extract all the shared libraries to common utilities, and also like to provide a shared reconciler layer wrapper to further reduce the code duplications. I think from users' perspective, the change is minimum. Instead of installing multiple operators, only one is needed in the future. So user doesn't have to manage that many manifest, and logs metrics SDKs will be unified. It will be easier to integrate with your like environment or systems smoothly. So I also like to take the version compatibility into the consideration. So in the first release, job APIs won't change. So users should have a very smooth migration experience. The major changes of this big story is on the controller side, and we need to do a lot of refactoring, but this is totally transparent to end users. I think alpha release will be at the end of July, and the beta is targeted for Kubeflow 1.4 release, which will be I think late August or early September. So once it's mature enough, we plan to rename the TF operator repo to Kubeflow training operator and archive some of the repos we don't need. So in the past year, I think we did a lot of refactoring work, but didn't spend too much time on the new features. So what's next? I think universal training operator clears the blocks and motivate most of the contributors to add more new features. So this will be the source of truth in the future. So we don't have to maintain that many operators at the same time. So we can briefly talk about the like the features we like to promote pretty soon. So the first one is to add more like details into the like the Kubeflow results, like parameter servers or like your job spec roles will be showing when you get the jobs, same as the job status. So you don't have to get the job and describe to check those like big YAML files. Yeah, so that's the one feature. And we also get a lot of users requests to submit the jobs using Git directly. I think a lot of users, they don't like to build the images and then use like Kubeflow or other APIs to trigger the training jobs. So this one smooth experiences or user journey we can provide is when you check in the code, and I think we will leverage some GitOps methodologies and borrow some ideas from Faring and build the training jobs for yourself and streamline the training process. So that means the time you're checking the code, we can kick off the training jobs for you. Yeah. The third one, I think, is more on the data set and the volume management side. So currently, training operators require users to provision the persistent volume separately, like creating the PVCs and then download data set into the volumes, which cause additional operation overhead. Similarly, like Git repo feature, I think we can add some support to help user easily manage their data sets and volumes. For example, like give your S3 data path to the operator, and the job operator will provision the volumes or acceleration cache layer like Alluxio for you to automatically reduce the operation overhead here. I think the last feature we like to do is to further reduce the duplication. We like to de-emphasize the differences between those frameworks. As Wang talked a lot of distributed strategy is pretty similar. So if we can support like custom role, user just tell the operator like the typology they like to use and the roles, so the operator will orchestrate the distributed job for you. I think if we can make that feature, technically it can support any new frameworks out of the box in the future. There's no big difference between those frameworks. Yeah. I think if you are interested in contributing these features, feel free to join us. Yeah, that's all my the talks today. So any questions to me and Wang?
Thank you for this great presentation, Jiaxin and Wang. This is really exciting. Do we have any questions from the community?
I have one.
Yep.
Earlier you said MPI operator is a special case because of its model. So is the current plan to completely exclude it from the unified operator or just from the shared code?
I can take that question. MPI is a little bit special. I think API side it will use the common types, but the implementation side is a little bit different. So currently, I think in the alpha part we didn't consider that in the alpha release, but later we will merge the code together. Yeah, so that's the plan.
I see, got it. Yeah, I think I'm interested in getting the MPI operator into Kubebuilder as well. So I could probably help with those implementations.
Cool.
So we can eventually migrate it.
Yep, sounds good.
I have a question here. So why we can't use just a common operator for MPI since they're using the sharing API? We can use just a separate reconcile for MPI, right? So it will not a problem.
Yes, we can definitely do that. I think the only problem is it's not like that similar as other ones. So we can reuse a lot of wrappers we built, but technically on the code side, we can definitely merge into one and reuse some of the methods. But the building the the topology wide is a little bit different.
Yeah, because as you mentioned before, guys, like I think it will be a very good user experience if we have everything out of the box. And if users just want to use MPI operator, they can simply modify the controller arguments and that's it. And they can use the same MPI distributed strategies for their code. Does it sound good to you, Aldo? Because
yes,
do you think the same way? Okay, go ahead.
Yes.
Hey, Wang, since you work more on the MPI side, do you have any more comments?
I think the MPI operator is a special case among different training operators. So the first step for us is to try to merge multiple training operators share the same architecture, like the PyTorch operator, MXNet operator, and TF operator. So we will further discuss with Terry and to make sure how we handle the MPI operator. If we technically see the promise to merge MPI operator into the all-in-one operator, I think it's a good idea to keep the code simple and within the same repository. But if we find there's multiple processing, like the access control cannot be merged, or maybe it can be merged, but we need to do a lot of efforts, we can leave it to the next step and see how it develops.
Yeah, I think to add to this, because currently, as Aldo contributed to the V2 version of MPI with using SSH and a lot of other good improvements, I'm not sure how we can move forward with the common implementation.
Yeah, I mean, yeah, I think like merging the operators share the same pattern is the first priority, and whether the MPI operator can be merged or not, we can further discuss. It's not the top priority right now.
Sounds good. Any other question? Yeah, go ahead, Josh.
Will there be some form of test plan or some way for like when users could take the beta or the alpha and go and test it? Is there something that might help users be able to test out this functionality as it and validate it?
Yes. So currently, the testing we have I think two parts. The first part is like the framework testing. I mean the Kubernetes like KubeBuilder level framework testing, because we rewrite the operators and the original like controller based I mean the low level controller based testing won't work for the new ones. I think we need to rewrite that part and have some general testing for the reconcilers, etc. And the second part is the previous end-to-end testing. So for that part, we will reuse those tests because that's very high level, like trigger the training jobs and check if it's overtime or job status if it's expected. For that part, I think we can use them for conformance test. And besides that, we do plan to add more tests to the repo before the beta release. And one thing we like to improve is the scalability test, because in the new design, technically we can save more, as I talked, save more resources by reusing the shared conformers, and also reduce the number of the calls to API servers. So that's a big difference compared to multiple operators in the past. So we will build some scalability like test plans and share more information later. Yeah.
Yeah, I think it's a very good point because like we can show this performance to our users and to see how this common operator actually improve their environment, which we discussed before. And since we're using the common controller, it definitely will help a lot of users, not only from the user experience side and more from the performance side.
Right.
Yep. Any other questions to Jiaxin and the common operators?
If I may again.
Yep.
Not a question, but rather a suggestion. Again, I said this before to a smaller community, a smaller venue. I'm part of the developers of the job API in upstream Kubernetes. So I would be highly interested in the providing all the features you need in the job API, so that whenever this migration is happening, your controller doesn't have to handle pods, but rather it could simply create Kubernetes jobs and let Kubernetes handle the pod creation, pod tracking, and all of those features, so you can focus on the training specifics. So yeah, let me know if you find this useful, and if there are missing features in the Kubernetes API, we can definitely introduce changes. I'm not a maintainer, but I have already some contributions, so I could advocate for those changes.
Yeah, I think that sounds good. I think in the past, we also follow the trends of the upstream. I know you proposed the index jobs and etc. So if technically, if Kubernetes have some like first party resource which can present the complex workloads like distributed trainings or some more like related like graph training, etc. If there's some resources can do that, I think that makes life much easier. Yeah, so yeah, I think probably we can put some time on the technical explorations on this part. We can use the native resources instead, that would be great. Yeah.
Excellent. Thank you.
I would also suggest to continue because this is very interesting and to continue this discussion, although it would be great if you can create an issue under Kubeflow TensorFlow operator. Because I don't know if Jiaxin already mentioned, but we will reuse like TF operator repository for our common Kubeflow training code in the future. So we can track like this issue there, what do you think?
Excellent. Yeah, I'll do that.
Yeah, so I will post it here. So yeah, because I think we can have like better integration with Kubernetes API there. Any other questions to training side?